Okay, today we're going to continue on with our study of exponents. Using exponents in mathematical expressions, equations. What we learned when we started talking about adding and subtracting with exponents is that when you add or subtract, the powers do not change. They will always stay the same if you are only adding or subtracting. With multiplication, that changes. But first, let's go back and let's talk about what does this mean. X to the second power means x times x. The base is x, and you're going to take that base and you're going to multiply it to itself with 2 of the bases. X times x equals x squared. Y to the third power would be y times y times y. Why? Oh, sorry. Variables can also be put together. A squared, b to the third would mean that you have 2 a's being multiplied and you have 3 b's being multiplied. Remembering also that if there's a variable that doesn't have a power written, the power is 1. And so what is actually happening here, when we multiply with exponents, if you'll look, there are 2 a's. The exponents are 1 and 1, and when you add the 1 and the 1 together, you get 2. For the b's, there's 1 and 1 and 1. 1 plus 1 plus 1 equals 3. So the b's are to the third power. So the rule for multiplying with exponents is you add the powers together for the like variables. So a to the x times a to the y, where x and y are both numbers, would be a to the x plus y. Alright, so let's practice this a little bit. Let's start with just numbers because we can quickly check those in the calculator. Right. 2 squared means 2 times 2. That's 2 to the first power times 2 to the first power. 2. 1 plus 1 is 2. 2 squared. And that equals 4. 2 to the third power is 2 times 2 times 2. 1, 2, 3. 2 to the third power equals 2 times 2 is 4. Times 2 again is 8. Now let's do it with variables. If I have x times x times x times x, each one of these has a power of 1. Remember, if there's not a power written, the power is 1. And this ends up being the base. Now 1 plus 1 plus 1 plus 1 is 4. X to the 4th. Y times y times y times x times x times x times x. Okay, we are only going to count the exponents for that particular base, and then we will summarize it by writing a variable with an exponent. For example, for the y's, I've got the power of 1, 1, 1. 1, 2, 3. Y's to the third power. For the x's, there are 1, 2, 3, 4. Power of 1, power of 1, power of 1, power of 1. X to the fourth power. And then I put it in the proper order. X comes before Y in the alphabet. And there we go. So a variable with an exponent is just telling us how many of those particular variables we have being multiplied together. 4 x's, 3 y's. Okay, so let's move on to something a little bit more complicated. Perhaps I've got 2x times 5x to the third. Okay, I'm going to regroup this, rewrite it, and I'm going to put like things by like things. Everything is being multiplied, so we can change the order without changing the value of this expression. Remember, this means multiply, and this also means multiply. So everything's being multiplied together. So I'm going to rewrite this as 2 times 5 times x to the third. Now I'm going to simplify this. 2 times 5 is 10. It's no different than the way that we've always multiplied numbers together. I've got x to the first, x to the third. I add them together, and that gives me x's to the fourth power. And that is done. It is complete. Now I'm going to do the same example again, because some of us are visual people and we need to see what's going on. So the 2 times the 5, it doesn't change. And then I have an x to the first power here. And then I have an x to the third power here. So I need to write down 3 more x's. And when you do it this way, it's just a matter of counting. 2 times 5 is still 10. And then we're going to have x's, and it will be 1, 2, 3, 4. There are 4 x's being multiplied together. Likewise, if you want to take an expression and you want to expand it like this, the power becomes very important on how to do that. So 6 to the fourth power, x to the third, y to the fifth, z. In all of this, here's what's happening. All right, the 6 is first. We've got 6 times 6 times 6 times 6. Now the x's. X times x times x. The y's. Y times y times y times y times y. 1, 2, 3, 4, 5. And then the z's. There's no power written for the z's. That means 1. So we just get 1. Now to put all this back together, I have 6. That's my base. And the power is going to be 1, 2, 3, 4. 6 to the 4th. X's, 1, 2, 3. So x to the third. Y's, 1, 2, 3, 4, 5. Y to the fifth. And z's. Z to the first. And this is the way you would write z to the first. One of the common ways that multiplying with exponents will be presented to us will be using the distributive property. So we'll start with a very basic example. Okay, in distributive property, everything on the inside of the parentheses gets multiplied by this factor on the outside. So we begin right here. 5 times x. There are no more 5's to increase this 5 with. There are no more x's in this one single term to increase this x with. And so this is just 5x. Plus, because there's a plus sign here. And now, here we go. X times x squared. The power of this one is 1. The power of this one is 2. So that gives me x to the third power. Now the question is this complete? And the answer is yes. All you have left now is addition. Although the bases are the same, the powers are not the same, so you cannot combine these two together. In the correct order, it would be x to the third plus 5x. All right, let's add a couple more numbers to this. So 2x squared times 2x minus 3x to the third. Here we go, one step at a time. Everything on the inside here is going to get multiplied to what's on the outside. Now I'm going to do this in 2 steps. First I'm going to do this multiplication and I'm going to write it this way. It's 2 times 2 x squared times x. There's 2 x's here, 1 x here, so it's 1, 2, 3. So it's not necessary to write the dot in the middle of the x's because when you put them right next to each other, it means multiply. Now the minus sign. So here we go. It's 2 times 3. So 2 times 3. And x to the second times x to the third. That's 5 altogether. So 1, 2, 3, 4, 5. Now for the last step, we're going to condense this, simplify it. I've got 2 times 2. That's 2 to the second power. And I've got x's next, and there's 1, 2, 3 of them. Now my minus sign, 2 times 3. All you can do is just complete that multiplication. And then we have more x's. 1, 2, 3, 4, 5. X to the 5th power. And that's done. To put them in the correct order, it would be negative 6 x to the 5th plus 2 squared x to the 3rd. And you would generally want to go ahead and do 2 squared, which is 4. So 4x to the 3rd. Okay. Now let's add a few more variables. 2x squared times 2xy plus xy squared. The only thing that's going to be increased on the inside of this parentheses are the coefficients, because we have a coefficient here, and the x's. There are no y's on the outside being multiplied that we can increase these y's with. So watch what happens. Okay, so the 2 times 2 is 4. The x to the second times the x to the first. That's 3 x's altogether, so x to the third. And then there are no y's to increase this y with, so its power stays the same. Now the plus sign. Now here we go again, the second term. 2. Well, there's not really a coefficient here. I mean, there is. It's 1. So 2 times 1 is 2. And now we have x's. There are 2 x's here. There's 1 here. So 2 plus 1 is 3. And now we get to the y's. There are no y's in this factor to increase the y's in this term. So it's just y to the second. And that's it. That's done. That's complete. Okay. So Sometimes we'll have something that looks like this. It looks big, bad, and ugly. So we'll call it Mr. Mackey. But really, it's pretty straightforward. Okay, ABC times ABC. Let's do A to the fourth, B to the third, C to the second, times A to the third, B to the third, C to the third. I'm going to regroup this, although it's not necessary. But what I have is A to the fourth times A to the third, B to the third times B to the third, C to the second times C to the third. And now I'm going to simplify. I've got A, B, and C. They're not going away. They're going to stay in there. The power of the A's is 4 plus 3 equals 7. The power of the B's is 3 plus 3 equals 6, so B to the 6th. The power of the C's is 2 plus 3 equals 5, so C to the 5th. Now always, if you are a visual learner, you can take expressions like this and you can expand them if it's going to make it easier for you. A to the fourth means A. B to the third means B. C. A. B. C. And now you just count. A, B, C. 1, 2, 3, 4, 5, 6, 7. A to the 7. B's. 1, 2, 3, 4, 5, 6. B to the 6th. C's. 1, 2, 3, 4, 5. C to the 5th. Isn't it wonderful? Absolutely.